So we're back. Let's keep solving logarithmic equations. So try to solve each of the following. Well, we're going to solve each of them by converting them into exponentials. Okay. So if I convert them to an exponential, this first one will get converted to 5 cubed is 3x minus 4. The benefit now is 5 cubed is just 125. So I can add 4 to both sides and divide by 3. Okay, so that's part A. Part B, yeah, you can check if you really want to, but it's definitely correct. So for part B, change this log into an exponential, and you'll get x squared is 81. Now, when you take the square root, it looks like you're going to get 2 answers, but you don't. Why not? The base of a logarithm cannot be negative, so only the positive base works. And you can then double check, yes, log base 9 of 81 is 2 because 9 squared is 81. Okay, just remember, the base of a logarithm can't be negative, so that's why we threw out a possible solution here. Okay, how about this? E to the 3x equals 7. Solve for x. Convert it to a log. If e to the 3x is 7, then 3x is the natural log of 7, which means x is just the natural log of 7 over 3. Now, the natural log of 7 is just a number. Okay, just like the square root of 7 is just a number. You don't have to approximate it. You can. Okay, this is totally okay. I would prefer this. Okay, if this is an exam or a quiz or something, if I see this, especially if it comes after this work, I know exactly what you did, I know how you got it, and I know it's right. If at the end, especially if it's after a whole bunch of very messy and hard to read work, there's a decimal approximation, I have to really dig into how you got it. Also, all you're doing is raising the possibility that you plug this into your calculator wrong and make an error, and then you'll actually lose points. As soon as you get this exact solution, just stop there. You are done. You are correct. X is the natural log of 7 over 3. Full stop. Okay, let's do a word problem. So blood alcohol concentration, it's a pretty self-explanatory term. It's how concentrated alcohol is in your blood. Okay, so relative risk is the likelihood of one event occurring divided by the likelihood of a second event occurring. So for example, okay, if I'll do an example that isn't the one that's given up in this problem. You might say, what's the risk of, suppose you're going on a trip, okay? You're driving. What's the risk of getting in a car accident? It's fairly low. What's the risk of your gas tank catching fire? It's also fairly low. The relative risk would be, what's the risk of getting in an accident provided that your gas tank has caught fire? That would be the ratio of the probability of getting in an accident divided by the probability of your gas tank catching fire. And you can imagine that's actually quite high. Okay, so even if 2 events have low risk, the relative risk might be high because one of them tends to lead to the other. So the example given here, if your blood alcohol concentration is 0.02, you are 1.4 times as likely to get in a car accident compared to someone with a blood alcohol of 0. So you'd say the relative risk is 1.4. So the current function essentially models your relative risk, where x is your blood alcohol percentage and k is some number that hasn't quite been figured out. I mean, we'll figure it out in the sample problem, but it's just some constant. So sorry, you should copy this down, okay, because we're going to use this formula a bunch. So it's quick, hopefully it only takes you a few seconds. R is e to the kx, where x represents blood alcohol concentration and r is relative risk. So if your blood alcohol concentration is 0.02%, which if I wanted to express it as not a percentage, that's 0.0002. If x is 0.0002, then r is 1.4. Find the constant k. Once you find that constant k, if you change the blood alcohol concentration to be 0.17, what's the relative risk? Okay, so go ahead and work that out. Then you can ask what blood alcohol concentration corresponds to a relative risk of 100. And in part D, suppose the law asserts that a relative risk of 4 is where you should not be able to drive. What blood concentration does that correspond to? Okay, so hopefully we took a pause and worked this out. So if I let x be 0.02, oh, I'm sorry, they let x was the blood alcohol concentration accounting for the percentage sign. So you didn't have to let x be 0.0002. This is a minor thing. It wouldn't really change a lot of the rest of the problem, but we'll follow the book's computation. X is 0.02, and r is 1.4. So I convert that to a logarithmic expression to get 0.02k is log of 1.4. Divide by 0.02, and let's go ahead and approximate this. Once you're going to use that value of k in other parts of the problem, an approximation gets pretty helpful. So k is about 16.82. The natural log of 1.4, which is not that big, but it's being divided by 0.02, which is a very small number, so it's being made much larger. All right, part B, suppose your blood alcohol concentration is 0.17. Incidentally, as long as we're going back, a blood alcohol concentration of 0.02 is like 1 drink for a normal-sized person. So after 1 drink, you are 40% more likely to get in a car crash. Suppose your blood alcohol concentration is 0.17. I believe the scientific term for a blood alcohol concentration of 0.17 is effing hammered. Okay, then you use k as 16.82, plug that in, and use x equals 0.17, and you get an r of 17.5. You are 17 times more likely to get in a car accident. Huge. Okay. Suppose you want to know what blood alcohol concentration would you have to be 100 times more likely to get into a car accident. We still know k is 16.82. We're not changing that. We're just changing r to be 100. So I let r be 100, I let k be 16.82, but now we need to solve for x, which means we're going to need to convert this exponential into a log. The natural log of 100 divided by 16.82 is about 0.27. So your blood alcohol concentration would have to be about 0.27, which is, I'm pretty sure, in the blacking out territory, if not beyond. That might be fatal. So the last part, suppose you want to make the legal cutoff to be a relative risk of 4. As long as you're not so drunk that you're 4 times likely to be in an accident, that's okay. As soon as you hit 4 times likely, that's where we want the legal limit to be. So now I know I want r to be 4, and we need to solve for x. This is the same problem as before. We're just setting r to be 4 and solving for x. So take a log, 0.082, which is about the legal limit in most states now. It's worth pointing out, over in Europe and a lot of the rest of the world, if not almost all the rest of the world, the legal limit is 0.02. As soon as you've had a drink, don't drive pretty much anywhere else in Europe. Here in the US, we're a lot more tolerant about it, and we say as long as you're less than 4 times likely to be in an accident, you know what, go ahead. Okay, but maybe you as a person decide 4 times the risk is unacceptable and you want to make your own personal cutoff a little lower. Anyway, that's the end of this section, so come on back for future videos in future sections. We're going to keep working with logarithmic and exponential functions.